What possible use could AI have in my operating room? Disappointment for those who are wanting robots that are going to do everything. I don't think that's what is going to be affecting us. We maybe don't think about it very much, but it struck me, this is a fantastic conference for seeing people at the absolute top of their game operating. But what is very obvious is that when you're operating, when you're the surgeon in the operating room, there's a huge amount of information cognitive load. Now, cognitive overload, we've got so many things going on that your brain is preoccupied and you miss the bigger picture. The situational awareness is a real thing. And I think that the big effect of the AI is being able to make sense of a lot of that data and helping reduce the overall load on the surgeon so that they can actually use their human intelligence, which is far more broad and far more general. And the key to this is something which is called context. So that is that the AI has a model of what the operation involves, so that's like a 3D model of the procedure, but also one over time as well. What are the expected steps through that procedure? And then it's taking the live feeds that are coming from 2D data sources, for the fluoroscopy from 3D data sources, from other any potential input. And it's updating its model of the procedure, and it's showing that information back to the surgeon. This is called context, which means the right information, the right time, and the right place. I mean, you can pick about just about any user interface that we deal with in our cars, on our phones, or anything else, but there's a lot of this around, and just look at a fighter jet from the 1980s, and I'd say that a lot of the stuff we've seen today, absolute top guns at work. But nowadays, what you have is the kind of the multi-sensor fusion going on, and a much more simple experience so that the pilot can use their brain for better situational awareness. They still get the alerts when they're relevant, but they're seeing everything in a much more integrated way. The key technologies behind this, first of all, it's the data. And it's the data to know all these different bits of information coming in, the 3D, the 2D, the annotations, the labeling of things as well. But it's also having really diverse data. So it's not just one idealized version of what the procedure looks like. And the reason for that is that the key piece of the ingredient is this thing called deep learning, which is these simulated neural networks that learn much the same way that we teach a child. We don't teach a child to recognize a cat by it's got pointy ears and whiskers. We show pictures of cats and it just learns. And that's really been a big breakthrough technology in all of this. The third bit, we touched on it earlier, is the cloud, because it's only by being on the cloud that you can actually connect all of that data together and connect it with really high performance computing that you need. And obviously you need to do this in an environment which is regulatory cleared from the data protection, information security, as well as the medical device sides. And that's really what we've pioneered at CIDAR. So what's the reality today? Well, the reality today is it's already simplifying workflows in the product. So automated segmentation of the relevant anatomy, this placing of rings on there is one click by the user, and all of that fine adjustment there is the deep learning in action. And yeah, that's a really complicated task. We would try to do it in 3D. And what we're doing, this is due for release in the early part of 2021, just going through regulatory at the moment. But actually a planning stage that produces a whole map of the procedure, not just a series of measurements, but a 3D rendering of how you want that procedure to end up. And then this is the key bit, that the information that's being generated through the course of the procedure is updating that model, what we refer to as a map, all the way through the procedure. So, for example, already in the product, the computer vision spots how the vertebrae have moved with respect to one another, and it's updating the CT scan and the map to account for the patient's posture on the operating table. There's none of this step which we've seen today asking a human to do this. This is something that the AI, the computer vision, is exceptionally good at, far better than a human could ever be. And then obviously it's the fact that it's just watching what is there on the screen. There's no other data feed going in. It's not shining X-rays or lasers or anything else. It's just seeing what you see, but doing that tirelessly and taking that mental job off you of matching what you can see on the screen to what you know about the anatomy. And then, as we saw with Tara earlier on, actually being able to update the anatomy for the real state of things at the time in a non-rigid way due to the stiff wires. But we're not finished. We've just released version 86, and there's a bunch of stuff coming through that is incredibly exciting. One of the bits about it is that these neural networks are very, very good at recognizing what you see on the screen. I think actually probably faster learning than humans. So this is some stuff where the neural net is labeling what it's seeing on the screen, delivery systems and deployed stents. And as soon as you have this, you now have one of the key ingredients of context, spotting the events as they happen in real time. And yes, it is working in real time. We have this behind the scenes. We're not showing it to users at the moment, but it's actually able to interpret what type of images it's seeing at the moment. We're doing lots of testing on it. But these are all the building blocks to bring it together so that we can show contextual information. Obviously, our final goal in this is to join all of this stuff up together so that when you come to plan a case, you can do it based on the results of patients with similar anatomy, similar procedures before. And the ultimate goal is that each new case is informed by all previous similar cases, and each new case contributes to the planning of future cases. So thanks very much for your attention. I don't know if we have time for questions. I'm very happy to answer them.
Yes, thank you very much, Tom. We do have a couple of minutes, I guess. Well, this technology makes me very hopeful for the future. If your third, fourth generation will be available before I retire, maybe I'll be able to plan one of these procedures myself. Thilo.
Yeah, thanks, and congratulations, Tom, on a great presentation. My question is, I have a very simple understanding of your technology. I probably only understand the surface of it. But what I understood is that your computers kind of track the shape of the vertebral bodies also. So they watch what we are watching, but they're seeing different things with a different data available. So my question, and so far they are tracking the vertebra. What I'd be interested in is, isn't the wall of the aorta so different in radio opacity that these fluoroscopies should be able to even track the ostia and see the ostia, or make the ostia visible and link the visibility of the ostia, which we don't see, but probably your computer can see, to the marked rings of the target vessel, so that your system would follow every deformation not by calculating it, but by actually seeing it.
Yeah, so we're on the same wavelength. So actually spotting the aorta itself is a bit of a problem. There are some patients who have nice bits of calcium in the right place and you can do it, but as soon as you do that, you're suddenly restricting how you're doing it. But there is a lot of information, you know it from operating, there's a lot of information that comes on the screen from where wires go, where catheters go, when you do give the contrast, that is giving us information on the current state of things. Seen a little bit, there's a new version just about to be released where when you do an angio, 2D, you're actually updating the model in 3D. So you go and pan somewhere else, come back, and now it's actually still accurate for where it is on the screen. But there's a huge amount there to be tapped with it. Yeah.
So another question, so how do you train the data? Because is it training with an expert, or did you let the computer train it by themselves?
So it's supervised learning. So in fact, a bunch of it is, so what you saw there with the rings, that's just our users were placing those rings manually, and then we feed in the results from the rings that they've placed into the 3D data set through the neural network, and it learns that way. So much of it is the users themselves effectively training it as it goes along. Some of it is data that we then train it on in a supervised way.
Okay, thank you. Very, very promising and exciting. Thank you very much.